This video is on something called reciprocal trig ratios. So we are familiar with three trig ratios: sine of x, which is opposite over hypotenuse, the cosine of x, which is adjacent over hypotenuse, and the tangent of x, which is the opposite over adjacent. However, there are another three reciprocal ratios of our trig ratios. Now, reciprocal means that we are flipping our ratio upside down. So the cosecant of x equals 1 over the sine of x, so it would be hypotenuse over opposite. We've got the secant of x, which is 1 over the cosine of x, which would be the hypotenuse over adjacent. And we've got the cotangent of x, which is 1 over the tangent of x, so that would be adjacent over opposite. We also have to remember our trig identity, tan x equals sine x over cos x, and that would give us that cotangent of x equals the reciprocal of that ratio, so it would be cosine of x over sine of x. A handy tip for remembering which of our sine x, cosine x, and tangent of x are related to the reciprocal is to look at the letters. So in cotangent and tangent, they're the only ones that have a t, so they're the reciprocal of each other. With the other two, they have the opposite letter. So cosecant of x is related to the sine of x, and secant of x is the reciprocal of the cosine of x. So for sketching graphs of the reciprocal functions, they can be sketched by looking at values on the graphs of the three main trig ratios. So let's look at the relationship between sine x and cosecant x in more detail. So here we have a curve of y equals sine of x. It's plotted between negative 90 and 360 degrees, and it has a range of negative 1 to 1. So we want to see how that would relate to our y equals cosecant of x, knowing that the cosecant of x equals 1 over the sine of x. So first of all, we're going to look at the roots. So the first root is at 0, 0, and the cosecant of 0 would be 1 over the sine of 0. And you can see from the curve that that would mean we were divided by 0, which would give us infinity. So on our sketch of cosecant of x, it's going to have an asymptote at x equals 0. So the next root on our y equals sine x curve is at 180 degrees. And so again, we would be divided by 0 for our cosecant of 180, and so again we have another asymptote at x equals 180 degrees. And the final root that we have for our y equals sine x for the domain shown is at 360 degrees, and so we're going to get another asymptote at x equals 360 degrees. So now that we have our asymptotes in place on our cosecant curve, we're going to consider the minimum and maximum stationary points on our sine x curve. So you can see that we've got a maximum at 91. So the cosecant of 90 would be 1 over the sine of 90, which would be 1 over 1, which is just 1. So we have a turning point on our cosecant curve at 91. And we can plot that in. Then we want to consider our minimum stationary points. So we've got one at 270, negative 1. So if we consider the cosecant of 270, that's going to be 1 divided by negative 1, giving us a stationary point at 270, negative 1 on our cosecant curve. Now, our maximum stationary points on our sine x curve will become minimum stationary points on our cosecant of x curve. And our minimum stationary points on our sine of x curve will become maximum stationary points on our cosecant of x curve. So we can then complete the graph using symmetry. And you can see that the curves are inverted and are never going to touch the asymptotes. So we've looked at the relationship between the sine of x curve and the cosecant of x curve. Now we want to think about what the secant of x curve would look like. So we can do the same thing. We can look at the cosine of x curve and then plot the 1 over the cosine curve to get our secant curve, looking at the roots and stationary points. We can also think about our transformations. We know that the graph of y equals cos x is the related graph of y equals sine of x with a vertical shift 90 degrees to the left. So therefore, the graph of y equals the secant of x is the related graph of y equals the cosecant of x with that vertical shift 90 degrees to the left. So we've got our cosine curve plotted from negative 90 to 360 degrees. Again, our range is negative 1 to 1. And we want to plot our y equals secant curve. So we know that there's going to be a 90 degree shift of our cosecant curve to the left. So therefore, our asymptotes are all going to shift 90 degrees to the left and appear at negative 90, 90, and 270. If we then take our cosecant curve, we're going to shift that 90 degrees to the left, and you can see that now we've got a minimum stationary point at 0, 1, and we've got a maximum stationary point at 180, negative 1, and we've got a final minimum stationary point at 361. So we can use y equals 1 over the tangent of x to sketch our cotangent of x curve in the same way. Our roots on our tangent curve become asymptotes on our cotangent curve, and our asymptotes on our tangent curve become our zeros on our cotangent curve. And just like our maximum stationary points become minimum stationary points on our secant and cosecant curves, as we tend to positive infinity on the tangent curve, we now tend to negative infinity on the cotangent curve. And so it makes sense that when we tend to negative infinity on the tangent curve, we now tend to positive infinity on our cotangent curve.